recap a little bit of what we know from previous. A polynomial is any function that has a coefficient and an x raised to an integer power. So x needs to be raised to an integer power. The leading term or the highest integer power is the degree of the polynomial. So if we look down here, we can see that it's a polynomial because the powers are 2, 1, and 0. And it's an x squared polynomial, so that's in fact a quadratic. The second one's also a polynomial because the integer powers are 4, 2, 1, and 0. So it's a polynomial of degree 4. The third one here is not a polynomial because it's raised to a negative integer value. So number 3 there is not a polynomial. If we have a look at the different expressions there, a quadratic function is one where the degree of the polynomial is 2. So in other words, the highest power is 2. So it could be just ax squared, 3x squared, a half x squared on its own, or it might have other coefficients with it. Looking at some of our expansion knowledge, obviously our perfect square is any expression completely squared. 3 squared is a perfect square, so in other words 9, or 4 squared, 16 is a perfect squared. And here's the rules that we can help to use to expand our terms. So if we consider 2x minus 3 all squared, we have the first term all squared minus, because it's a minus inside, 2 times 2x times 3 plus the last term squared. Okay, so if we expand all that, 4x squared minus 12x plus 9. Of course, if we just use a slightly longer way, 2x minus 3 all squared is 2x minus 3 times 2x minus 3. So if we just expand our brackets, 2x by 2x is 4x squared, 2x times negative 3 is minus 6x, negative 3 times 2x is minus 6x, negative 3 times negative 3 is plus 9, 4x squared minus 12x plus 9. Same answer. Second problem, same thing. We can do it the long way, or it's the first term squared plus 2 times the first term times the second term plus the second term squared, which gives me x squared plus 2 root 2x plus, well, root 2 squared is root 2 by root 2, which is root 4, which is 2.